Okay. Now, guys, today we are going to start with the network layer 3. Okay. So in layer 3, we'll be talking about the packets. Packets. Okay. Or the layer 3 PDU is the packets. Now, let me start with the functions of layer 3. Okay. So layer 3 functions or network layer functions. Network layer functions. So main 3 functions are there. The first function is called routing. First function is called routing. Okay. Let me tell you. So here we have, say, this is our classroom and we got many computers here. In our classroom, we got many computers. Now, these computers are interconnected using a switch. So again, we have connected it here, interconnected using a switch. Now, again, suppose in another classroom, we got another network, or we got another set of computers and they are interconnected using another switch. Okay. So you can now give an IP address. You have studied the IP address and all, right? So here, suppose you are giving an IP of the range 10.0.0.0 network. Then you can give the IP, assignable IP, you can assign it like this, 10.0.0.1. Here you can give 10.0.0.2, 10.0.0.3 like that. You can give multiple IPs here. Okay, same thing. Suppose you got another network here, which is 20 dot network. 20.0.0.0 network is there. Okay, now you can give the IP, suppose 20.0.0.1, 20.0.0.2.3.4.5, etc. Clear? Now, you got one network here and another network. So these two networks are connected using a device called router. These two networks are connected using a device called router. So router is used. So let me draw the symbol of the router. So we'll draw a perfect circle. This is not a perfect circle, but when you draw it, try to make it as a perfect circle. Okay. Now, 2 arrows outside. You can see, yes, 2 arrows outside and 2 arrows inside. So this is the symbol of the router. Okay. Now, so here, then you will connect one network. So these networks will be connected to a router. Okay, so this is the router. And router, how many interfaces has the router have? Say minimum, they need to have 2 interfaces. So these are the interfaces. Now, so to left side of the router, you have one network, and to the right side of the router, you have another network. Okay. Now, let me tell you what is routing. So routing is the process of sending packets from one network to another network. Routing is the process sending packets from one network to another network. Routing is the process of sending the packets from one network to another network. Okay. Now, so if suppose this machine, which is having the IP 10.0.0.1, wants to send something to 20.0.0.1, the router needs to route the traffic from one network to another network. Clear? That process called routing. And regarding routing, we have a major section called routing itself. So the later things will be studied in that section. Clear? Now, that's the first function of network layer. Now, let me go with the second function, which is called layer 3 or L3 addressing scheme. L3 addressing scheme. L3 addressing scheme. You have already studied this. Okay, the basic things you have already studied. What is L3 address? Okay, or IP address you can say, right? So L3 address is the, say, IP addressing. So IP address is called the L3 address or the network layer address, or say layer 3 address. Okay, so that the basic things are already you have studied it. Okay, so if you got an IP, then you know which class it belongs to. You need to you know how to find the subnet mask, the default gateway. Sorry, not the default gateway, the subnet mask, the network address, broadcast address, and the assignable IP address. Clear? Okay. So this is the L3 addressing scheme. So the L3 address is the IP address. So another function of network layer is to provide the L3 address or the IP address. Clear? Okay. In network layer, again, we have multiple protocols. Okay. CLNS, connectionless network service. That is one protocol. And second protocol is IP. IP is the most widely used one. Okay. So IP, you know, IPv4 and IPv6. Okay. And you might have heard of something called Apple Talk as well. Apple Talk, which is used in Apple products. Right. So you have different protocols working in L3. So these are some examples of the L3 protocols. Okay. Now, so this is the network layer. Okay. The second function of the network layer. And let me tell you about the third function. Third function is called fragmentation. It's called fragmentation or fragmentation and defragmentation. Fragmentation and defragmentation. Okay. Now, let me tell you what is this fragmentation and defragmentation. Suppose, so in the transport layer, we have discussed about the segmentation process, right? So when we discuss the segmentation process, we have talked about the source machine and the destination machine. Yesterday, I remember teaching you, suppose the source is sitting in India and the destination is sitting in US. Okay. Now, so we are not really connecting it directly, right? From this computer, we are not really connecting it directly. We have in-between devices as well, right? So suppose, yes. Okay. So now, so you got this router here. Suppose you are connected it to a, say, a switch and a router. Okay. Suppose we are connected it to a switch and then to a router, R1. And from router, we are connected it to another router, R2, another router, R3, the next router, R4, next router, R5. Then from R5 to switch, and from switch to computer. Okay. Now, so guys, we have connected multiple routers. So we have many in-between devices. Now, the in-between devices, so here we'll consider the in-between devices as well. So considering the in-between device, suppose R2 and R3. R2 and R3. So let me take R2 and R3 here. So you got R2 router and you got R3 router as well. So this is the connection from R2 to R3. Now, suppose this machine, this source machine or the machine in India is trying or he's sending multiple packets to this machine in US. He's sending multiple packets. Okay, suppose he's sending 1,000 packets. He's sending 1,000 packets. Okay, now suppose this is the 100th packet. This is the 100th packet. Now, so considering the in-between devices, so we in the transport layer, we have discussed about the segmentation that was based on the source machine and the destination machine only. Okay, here we are taking the in-between device also. Now, the in-between devices, they have a capability. Suppose we have, who is it? Susmit. Okay, so Susmit, suppose, okay, so suppose he's a gym guy. He's a gym guy. Now, he can lift 100 kilo. He can lift 100 kilo. Suppose he can lift a bike. Maybe the John Abraham force, right? Yeah. Okay. So he can lift 100 kilo. Okay. So he can maximum lift up to 100 kilo. That is his maximum limit. Okay. Similarly, the routers can forward the packets. The router can forward the packets and they have a limit. Okay. Means the size limit. The size limit is called MTU or it's called maximum transmission unit. Maximum transmission unit. That means, say, R2 can forward a packet. He can forward a packet, say, with max, suppose the MTU value is 1500 bytes. This is the default value. This is the default value. That means the router has a capability to forward a packet with maximum a size of 1500. Suppose if Susmit is given, say 100 kilo, he can lift it and place it somewhere. But if he is given 200 kilo, what he will do? He cannot do it, or he will have to split it into two parts. Again 100 kilo and again another 100 kilo. So the same thing, the size. So the routers or the in-between devices will have a capability, and that capability is known as maximum transmission unit. That means it is the maximum, say, the packet size which can be forwarded by the router. Clear? And the usual value will be 1500. Clear? 1500 is the MTU size, usual value. Okay. Now, so here, suppose the MTU of R2 is 1500 bytes. MTU of R2 is 1500 bytes. Now, these packets which are coming, I told you, say these computers are sending multiple packets. Okay. And each packet is having a size of 4500 bytes. Suppose, just as an example, suppose each packet has a size of 4500 bytes. If say a packet with 4500 bytes is received at R2, he will not be able to transmit it. Yes.
Does the packet have a maximum capacity?
Yes, of course. The packet have a capacity means, say again, let me tell you, at the transport layer, what happens is that at the transport layer, say this is the transport layer. So the transport layer, what they will do is that during the connection establishment, the source machine and the destination machine will share some information with each other. They'll share maximum segment size value and all. That means it is the limit of the source and the destination. They'll share the maximum segment size. They'll share some buffer status. They'll share many multiple things and all. And based on that, they will start sending the packets, or they'll start sending the segments. Okay, suppose this source machine has a capability to send, suppose 5000 bytes. This is regarding the transport layer only. Okay, so this source has a, say, a capability to send 5000 bytes of data. But suppose the destination is only able to receive 3000 bytes of data. Then they will negotiate, or they will send these things each other. During the connection establishment, I told you that, say, three-way handshake happens. And during the three-way handshake, these things will happen. Okay, they will mutually share their known routes, these things and all. Okay, so then they will come with a certain value. So then they will decide, okay, we will send the segments using 3000 bytes. Clear? Then, so they will send. So the maximum segment size here will be 3000 bytes. Then they will add the header, the TCP header, which is, say, 20 bytes. Suppose it's 20 bytes. Then this value will be 3020 bytes. The segment, okay, the size of the total size of the segment is 3020 bytes. Then when it comes to the network layer, say this is where you add the network header, and the network header has a size of minimum 20 bytes. So what is the packet size here? The packet size here is 3020 plus 20. Then it is 3040 bytes. Clear?
Yes.
Okay. So now that is how, say, then suppose he is receiving some, say, bigger packets. So then the router, suppose he has not a capability to send or transmit that much, say, higher or that much, say, the bigger values of packets, bigger sized packets. Okay. If he is not capable, what he is going to do is he'll fragment the packet. He'll fragment the packet. Okay. So he will divide the packet into multiple smaller units. Clear? Okay. So Smith. Okay. So don't think about that 100 kilo and all. Okay. Your gym is over. Okay. So now, so here, say, so suppose this is the big packet here. This is the 100th packet. This is the 100th packet, which is having the size of 4500 bytes. Then this packet, say again, let me delete it. So this packet will be divided into, suppose they are dividing or they are fragmenting into 3 units. Okay, fragment into 3 units. So here, the first unit has, say, this consists of 1500 bytes, and this also consists of 1500 bytes. And this also consists of 1500 bytes. Okay, now, so this is the 100th packet, right? So you can say to identify the packet, to identify whether it's the 100th packet or the 200th packet or the 300th packet, we have a value called identification. We have a value called identification. So the identification will be, here it is 100, because it's the 100th packet that we have fragmented. Clear? Now, this is the 100th packet first fragment. It's the first fragment of the 100th packet. Okay, so to identify the fragments, so this is the first fragment, this is the second fragment, this is the third fragment. To identify the fragments, we have a value called fragment offset. We have a value called fragment offset. Okay, now again, you got 3-bit values, certain bit values. Okay, as you have studied in the TCP flag, we are going to study, say, some IP flag values here. IP flag values, say, which has 3-bit and it's called X, D, and M fields. X, D, and M. X means evil bit. It's called evil bit. It is a constant value. Okay, we'll not change the value. Whatever it's that, it will be there. Okay, now D is called don't fragment. It's called don't fragment bit. Okay, and this is called more fragments. More fragments. Okay, so first is the evil bit, the value remains constant. And you have don't fragment bit and more fragment bit. So the first value remains a constant X. That remains a constant. Then the D, say it is fragmented. So it will be 0. So if this bit is set, that means the packet shouldn't be fragmented. Suppose, say Susmit is given, say some a very big packet weighing 200 kilo. It says don't split. It says don't split. Okay, 200 kilo. So he'll not be able to transmit it. Getting it? So he'll discard it. That's it. So if this bit is set, then fragmentation will not be done or occur. Okay, that's it. Now, so this is fragmented, so it is 0 now. Okay, now after this fragment, you still have some more fragments, right? So more fragments are there. That means this bit will be 1. Clear? Okay, the same thing here also. This value remains the same. Then it is fragmented and you have more fragments. This time here the constant value, then it is fragmented, and after this you do not have any more fragments. So this is 0. That means no more fragments are there. Clear? So this process of dividing a packet with, say, the packet size is greater than MTU. If the packet size is greater than MTU, then that means the maximum transmission unit, then it will be fragmented. Clear? Now, once these bits or these packets receive the router will defragment it, or they will say whatever say we have fragmented, they will everything that they reassemble and will be, say, like considered as a single packet. Clear? Okay. So this process is called fragmentation and defragmentation. Okay. So if you want to write, you can note it down. Okay. Done, guys. Okay. Now, so this is the network layer. These are the main three functions of the network layer. So first is routing, second is L3 addressing scheme, and third is fragmentation and defragmentation. Okay. Now, one thing I forgot, say, while teaching you IP address. Okay. So I told you that, say, or I might, or I didn't, I suppose I didn't have time to tell you. Okay. I suppose I didn't tell you about how to set the IP address in the computer, did I? No. Okay. So let me teach you how you can set an IP address in the computer. Okay. So now what you're going to do is you will take the run. You will take run, or you will press Windows plus R button. Okay. So now let me magnify. So you will take run, and what you're going to do is you're going to give the command ncpa.cpl. ncpa.cpl. Okay. Network connections. ncpa.cpl. Okay. Then you will give OK, and a new pop-up will come up. The network connections pop-up will come up. Or you can take like this as well. Okay. You can say go to, let me just, yeah, control panel also you can go, or yes, let me just minimize it, guys. Just give me. Okay. So now let me take the magnifier again. So many methods you can take. You can go to the control panel and you can take it, or you can say, you can click onto this while say your whatever the Wi-Fi or your internet, the wired internet connection, you will have a computer like symbol, right? Then you can right click it and open network and internet settings. Okay. Just a minute. So now, then you can take, after taking, you can take the change adapter options. So the same thing, the same pop-up will come. The network connections pop-up will come. So once you take, so now you have got the network connections, and then you will take the required adapter. Suppose your computer will have many NICs, suppose maybe your 1 or 2 NICs you may have. Say, or you may have a wireless NIC as well. So this is the wireless connection. Wireless connection. You can, I suppose you can see, read it, right? Okay. So this is the wireless connection. So if you want to take the wired connection, you can take it, or the wireless connection, whatever you want, whichever say adapter you want, you can take it. You can double click it and say you can see IPv4. You can see something which says IPv4. You will double click it. And now you can see use the following IP address. This is the prompt that they are asking. So you will give an IP. Okay. You will give an IP, say suppose we are giving an IP, say 200 dot. Okay, suppose we are giving a class C IP. So 200.128.15. Say 34. Okay, 34. And when you click the subnet mask, it will automatically get filled. Clear? Okay, so this is the default subnet mask. 255.255.255.0 is the default subnet mask of class C IP. Similarly, say you can give another IP. Say suppose want to give class A. Say suppose 10.1.2.3. Some IP is given. Say then if you click, they'll automatically fill the default subnet mask, which is 255.0.0.0. Then you can, just a moment, guys. Okay. So then you can click OK. Okay. Then again OK. The same thing. And if you want to see the IP address, if you want to see the IP address that you have set it, okay, you can take again the run, then you can take the command prompt CMD, or in the say search button itself, I mean the Windows, this one itself, you can type CMD command prompt. Then you will get the command prompt where you will type the command, say ipconfig. You can type this command, or you can type ipconfig /all. /all also you can type it. So this is the command. So once you type it, so now let me, yes, okay. Once you type it, you can see, say it depends upon how many interfaces you have. You may have many interfaces. Some virtual interfaces will be there when you have installed some software, some virtual interfaces will be there. Okay. So, or say you can see, say this is the Windows IP. So this is the LAN connection. This is the wired connection. But as this is disconnected, okay, it is disconnected. Here you can see the cable. So you have a cross mark is there. So that means I have not connected the cable. If at all it is connected, then you can see the IP address and all. Clear? You can see the IP address and you can see its MAC address, those things. But MAC, I suppose you can see, yeah, this is the MAC address. Okay, this is the physical address and this is the MAC address. Clear, guys?
Yes.
Okay, so this is how you will see these things. Okay, now, so this is it. Now, so shall we go to the next one now? So network layer, then what is the next layer? Data link layer. So whenever somebody asks you the layer about the layers, you must be able to deliver it at that moment itself. So if somebody asks you which is the which is layer 4, which is the layer 4? Transport layer. You must be able to say, if you are sleeping also, you should be able to deliver it at that time. Clear? So that's the thing. Now, so and before going into the data link layer, again, one more thing needs to be studied, which is the IPv4 header. Okay, so you can just write the heading IPv4 header. IPv4 header. Okay, so suppose if you are using IPv4 address, then the header will be IPv4 header. And the IPv4 header contains many values here. The first value is called version. It's called version. It says which version of IP it is, whether it's IPv4 or whether it's IPv6. Now the header length. Header length means the size of the header. The size of the header means how many, what is the size? Say the header size can vary from 20 bytes to 60 bytes in some cases. It can vary from 20 to 60 bytes. Clear? Okay. Now, the next one is called priority and type of service. Priority and type of service. So priority means, suppose, say, suppose lot of packets are coming to the router. Router will be giving priority to the packets. Router will be giving priority to the packets. Some packets will be processed faster. It will be processed faster. Suppose, let me go with this. So, do you need examples for these things and all? It's not necessary, right? Okay. So say this. So if you have, or if the packet has a priority, then it will be mentioned or it will be marked here in this field, priority and type of service. Clear? Okay. Now the total length. The total length. The total length means it is the header size plus the data size. It's the header size plus the data size. That's the total length. Okay. Now, identification you already know. What is identification? To identify the packets. Any doubts? Any issue? Sure. Okay. Now, flags. 3 bits are flags. You got 3 bits as flags. So let me tell you about the 3-bit. This is the IP flag. I've already told you about it. X, D, and M. X means it's evil bit. D is the don't fragment bit, and M is the more fragment bit. Clear? So this is the IP flag. Clear? Okay. Now you have another value called fragment offset. You have a value called fragment offset. Fragment offset you already know. It is used to identify the fragments. Okay. Then time to live. It's called time to live. So let me tell you what is time to live. It's not really time. It's not the time. Okay. So now let me tell you time to live. Suppose we got 2 computers. Now, say if we have routers like this, R1, R2, R3, R4, R5, like this. So this R5, this R1, R2, R3, R4, now R6, R7, R8. Okay. Now guys, so suppose the first machine is sending something to the second machine. First machine is sending something to the second machine. So he's sending, see, yes, he's sending something. Okay. And this packet will go to R1 and will go to R2. And suppose it's going to R6, again going to R1, again going to R2, again R6, like that. There are chances that a loop will occur. A loop will occur. Or there are chances that layer 3 loops may occur. Okay, to avoid the layer 3 loop, we have a value called time to layer. It is a number. It is just a number. It means, say, suppose whenever this computer is sending something to the router, he will set a value. Suppose it is suppose it's 255 or 256, or suppose 128. Okay, suppose the computer is setting a value 128 and it is sent to R1. Now, when the router R1 forwards this packet, he will decrement one value. He'll decrement one value. So this value 128 has now become 127. Then when R2 forwards it, he will also decrement one value. So this value has become 126. Then when R6 forwards, he'll also decrement it. So 125, 124, 123, 122, 129, like that. It goes on till it becomes 0. Once this value is called time to live or TTL. So once this TTL field is 0, then the router will not forward the packet. He understands it's in a loop and it has to be terminated. Clear? That's how we say avoid the layer 3 loops. Layer 3 loops are avoided using this field called TTL. Clear? So this is how you will avoid layer 3 loops. Now, the next thing. Where is it? Okay. Now, so that's the TTL value. So next field is called protocol. It's called protocol. It says which protocol it is, whether it's TCP, whether it's UDP, like that. You have multiple. Say if it's TCP, then the value is 6. Here it will be 6. If it's UDP, then the value is 17. Here the value will be 17. Clear? So you got different protocols. So those protocols will have different values. Okay. So this is the protocol number. Okay. Now header checksum. Header checksum is a simple error checking mechanism. Simple error checking mechanism. Now you got source IP and the destination IP. So if the first machine is sending something to the second machine, then the source IP will be the IP address of the first machine. Suppose 10.0.0.1. Okay, is the IP address of the first machine, then the source IP will be 10.0.0.1. Now, if this machine has got an IP of 20.0.0.1, then the destination IP will be 20.0.0.1. So that's the source IP and the destination IP. Okay. Now, even the IP also will have many options value. The MTU or those things will be there in the options value. Clear? So this is the options, and later it comes the data, or inside you will have the data, or it is the segment. Clear? So this is the IPv4 header, and this is the network layer. Okay. Yes. Now we'll go to the next one called data link layer. It's called data link layer. Data link layer. So now So the data link layer, it acts as an intermediate layer, or you can say it acts as a, say, you can say an intermediate, okay, between the network layers, or say you have upper layer, sorry, not the upper layer, the upper one, which is called the network layer, which will be, say, these things are all inside the software things, or say kind of we can't see it, okay. And we have physical layer, which is the, say, this values, the hardware things, okay. So it will act as an intermediate between the soft things, or the ones in the software and the ones in the hardware. Clear? So now again, suppose this is the network layer. This is the data link layer. And this is the physical layer. Okay, so you have network layer, data link layer, and physical layer. Now this data link layer itself are of two sublayers. It can be divided into two sublayers. The first is called LLC sublayer. It's called LLC sublayer. LLC means logical link control. Logical link control, LLC. Okay. Now the next one is called MAC sublayer. MAC you already know, media access control. Media access control. So the LLC is responsible for the interaction between to the, say, network layer and all, okay, to the software things. And MAC, media access control. So media, it's already there. So it is responsible for interacting with the physical layer, the media. Clear? Now, so these are the two, and LLC, it partially overlaps with the network layer as well. It partially overlaps with the network layer. Clear? Now, done. Okay. Now let me go with the data link layer functions. Data link layer functions. Okay. So here data link layer functions. Where is it? Okay. The first function is called framing and deframing. Framing means, so this is the packet. The packet structure you already know, right? The hi message, right? Then the application header, presentation header, session header, transport header, network header. So this is the packet structure. The packet is encapsulated with the data link layer header and data link layer trailer. So this process of encapsulating the packet with data link layer header and trailer is called framing, and removing the header and trailer is called deframing. Sure. Now the second function is MAC address discovery, which is very, very, very important, that we will talk about at the, talk about it at the last, as the last thing we'll talk about. So here MAC address discovery. Okay, and another function is there, switching. It's called switching. Suppose this is the switch. So switch is the device which works in data link layer. Okay, so now suppose you got many computers and you're connected it to a switch. So suppose you are sending something from the first machine to the second machine. Okay, then what happens is that, let me tell you, say first machine is sending something to the second machine, the switch will forward this frame from this interface to another interface. So just forwarding the frame from one interface to another interface is called switching. Clear? Getting bored, guys? Sure. Actually, let me tell you. So you guys might have come to study networking, or when you hear the term networking, say most probably you will have the like configurations or those things in mind, right? Definitely we'll come to that part, but we'll have to go with some theory portion at first. That's why we are going with the theory portion. Okay, so these are just the basic things. After that, we'll go with the, say, the configuration things and all. Clear? We'll discuss about, say again, each concept has a theory portion. That is okay. So we'll discuss the theory and later we'll come on to the practicals or the, say, configurations. Clear? Okay. So now, so this is the process of switching. And the next function, layer 2 addressing scheme. Layer 2 addressing scheme. You already know it, which is the MAC addressing. Which is the MAC addressing. Clear? Okay. And finally, you have something called error checking mechanism as well. Error checking mechanism. So in error checking mechanism, let me tell you, what happens is that the packet is encapsulated with a data link layer header and data link layer trailer. So what happens is that this is the header and this is the data. So the header value and the data value are added together and stored as a complex function in the data link layer trailer. So header value and data value is added and together it's added using some, say, some algorithms and all, and it is stored in the data link trailer. So that when the receiving machine receives it, he can also calculate it. He can check whether he can just add the header and the data value. He can add the header and the data and check whether it is equivalent to the data link trailer value. If it is not equivalent, somebody has tampered this information. He can understand. Then he can come to know about the error and he can, if at all it is not matching, he can discard the frame. He can discard the frame. Clear? So that is the error checking mechanism. Okay. Yes. So this is the next function. Okay. And the last function. Okay. The last function is called MAC address discovery. Okay. So you can write the heading MAC address discovery. So after this, we'll give you a break. I suppose at least somebody might have got bored or something. I can see some guys' faces and they seem to be bored. Okay. Not telling anyone's name. Right. Okay. Yes. Now, MAC address discovery. So now, let me draw here. Suppose you got 4 computers. Computer 1, computer 2, computer 3, and computer 4. These are 4 computers. Now, suppose these 4 computers are connected using a switch. Okay, here you have a switch. Now, let me tell you. Suppose machine 1 wants to send something to machine 4. Machine 1 wants to send something to machine 4. Then what happens is that, suppose this is the message, hi message, right? It is passed through each and every layer. So it is passed to the application layer, presentation layer, session layer, transport layer, network layer. So this is the packet structure. So the packet structure, or this, say, let me draw the packet structure here. Suppose this is the packet structure. This packet structure has got, and say the field will be source IP and you got destination IP fields. You have studied that, right? So in the network header, I've taught you about source IP and the destination IP. So suppose the IP address for this machine is 10.0.0.1. Okay, here the IP is 10.0.0.2. Suppose here the IP is 10.0.0.3 and here the IP is 10.0.0.4. Similarly, suppose it has a MAC address of MAC1. I'm not writing the MAC address, just writing MAC1, MAC2 like that. Okay, so suppose this is MAC2. This machine is having the MAC address MAC3 and this machine is having the MAC address MAC4. Clear? Now, so the source IP, what will be the source IP, guys? If the first machine wants to send something to the 4th machine, what will be the source IP? 10.0.0. I didn't hear anything. 10.0.0.1. Are you sure?
Yes.
Paka? Paka? Who says Paka? 1, 2, 3, 4, 5, 6. What about here? What about here? Sorry?
Yes.
Yes, sure.
Sure.
Okay, then that's right. Okay, so 10.0.0.1. Okay, so this is the source IP. And what is the destination IP? 4, right? So 10.0.0.4 is the destination IP. So destination IP or the IP address can be found out by, say, DNS protocol and all. The IP address can be found out by using DNS. Okay, so now, so source IP and destination IP is there. Now moving into, so now it will be passed to the data link layer. Okay, so the data link layer, suppose this is the data link layer. So let me give another color. So suppose this is the data link layer. The data link layer will add a data link layer header and a data link layer trailer. So the data link layer header will be having source MAC address and also destination MAC address. The source MAC address and the destination MAC address. Okay. So the source MAC, what is the source MAC? MAC 1, right? So MAC 1 is the source MAC. So let me write it here, MAC 1. And what is the destination MAC? MAC 4. But there is a problem. We know it is MAC 4, but computers, they doesn't know the MAC 4 and all. Okay, so or the destination MAC will be unknown to them. The destination MAC is unknown to them. So what will they do if the destination MAC is unknown? So that is what we will discuss in MAC address discovery procedure. Clear? So now say here, let me so the destination MAC address is unknown. Again, a moment. Sorry. So source MAC address is MAC 1. MAC 1 and the destination MAC is unknown. Okay, so you need to find the destination MAC address or the MAC address of the machine 10.0.0.4. So you have the IP address, right? So you will find out the MAC address using the IP address of the machine. So to find out the MAC address using the IP address, you will use a protocol called ARP. You will use a protocol called ARP. It's called Address Resolution Protocol. Address Resolution Protocol. Address Resolution Protocol. Okay. Address Resolution Protocol. Okay, now what the first machine will do is that he will use ARP or Address Resolution Protocol to find out the MAC address of the fourth machine. Okay, for that he will first send an ARP request or an ARP Address Resolution Protocol request. Okay, so this is called request, Address Resolution Protocol or ARP request, and the ARP request will be of this structure. So this will have an ARP header. It will have an ARP header. ARP header. And the ARP header will have the target IP. It will have the target IP. To which IP is it targeted? It is targeted for 10.0.0.4 in order to find out the MAC address of the device. Okay, so the target IP will be 10.0.0.4. This will be the target IP. Clear? Now, it needs to find out the target MAC. So the target MAC is nil. The value is nil. Okay. Now, along with this ARP header is encapsulated by using a layer 2 header. or an Ethernet. So it is also called Ethernet or layer 2 header. So the layer 2 header here, L2 header. Okay. Now the L2 header will be having source MAC and destination MAC. The L2 header will be having source MAC and destination MAC. The source MAC will be the MAC address of the source, which is the first machine. So the source MAC will be MAC1. It will be MAC1. And the destination MAC will be the universal broadcast MAC address. It will be universal broadcast MAC address. It is the broadcast address. Or the value here is FFFF. It's a specific value. Okay. FFFF dot FFFF dot FFFF. So this is the destination MAC address. This is the destination MAC address. Okay. Got it? Okay. So this is the destination. So now once it receives at the switch, or once the switch receives it, so the switch will flood it. The switch will flood it because it's a broadcast. It's a broadcast. So it will be sent to machine 2, it will be sent to machine 4, and it will be sent to machine 3 as well. But it will not send to machine 1. Clear? So it will do the flooding. Then machine 2 receives it, 4 receives it, and 3 also receives it. Okay. Suppose if you receive a letter, suppose Deva. No. Yes. Okay. Raghavendra and Deva. Got it. Okay. So now, so if Deva receives a letter, what will Deva check? Whether it is destined for you or not, right? So the to address is Deva or not, right? So the same thing the computers will also check. The computer will check whether the destination is his address or not. So the destination MAC, so it is received through the physical layer, and first is passed to the data link layer. So where they will check the destination MAC, whether it belongs to him or not. Okay, so here the machine 2 will check it. The destination MAC is universal broadcast MAC address. That means it is also for him. Okay, so if I tell hello, good evening, students, it is all for everyone that I'm telling. It's a broadcast, so it's for everyone that I'm telling, right? So the same thing. So it's the destination MAC is universal broadcast. Then the machine know, okay, it is also intended for him also. Okay, then he will forward it to LLC. He will forward it to LLC, and the LLC will check whether the target IP is his IP or not. The target IP is his IP or not. Clear? So what about the target IP? The target IP is 10.0.0.4 and the machine 2's IP is 10.0.0.2. So he understands, okay, it is not sent for me. So then what he'll do? He'll discard it. He'll discard it. Clear? Okay. Now, so this is discarded by the second machine. The third machine will also do the same thing. He'll compare the IP address with the target IP and say it has an IP 10.0.0.3, so which is not equal to the target IP. So he'll discard it. Now, what about the fourth machine? This fourth machine will compare it. The LLC will compare it and he'll get to know that it is at the ARP is actually sent for this machine. Clear? Then he'll send back a reply. He'll send back a reply. So this reply is called ARP reply. It's called ARP reply. So the reply will be having the MAC address. Say it is having the IP address 10.0.0.4 and the MAC address as MAC4. Okay, and then it will be then passed to the machine 1. So machine 1 now knows for 10.0.0.4 the MAC address to be used is MAC4. So the destination MAC is known now. It is now MAC4. Clear? So now he can send the packets, or now he can send the frames or whatever the messages he can send. So this is the process of MAC address discovery, and MAC address discovery is done with the help of a protocol called ARP, Address Resolution Protocol. Clear, guys? Okay. So now one more thing, the last and final thing. Okay, in the ARP itself, last and final thing. So after some time, suppose again, first machine wants to send something to the fourth machine. The same thing. So again, after some, say, suppose after 2 minutes later, he wants to send something. So again, whether he has to send the ARP request or not, right? That's a question. So you'll be having a doubt, right? Say after two, what about after 2 minutes? After 2 minutes, if he wants to send something to the fourth machine, actually, he does not require to send an ARP request and all, because he will save these values. For 10.0.0.4, MAC4 needs to be used. He'll save it in a cache table. And that table is called ARP cache table. It's called ARP cache table or ARP cache table. ARP cache table, which will have the IP address and the MAC address. If it is for 10.0.0.4, if he wants to send something to 10.0.0.4, then the ARP table will now have, say, the value, which is MAC4. Then he will fill it and he will send the frame. Clear? Okay. So this is the thing that happens. Any doubt? So now today's task. View your ARP cache table. View your ARP cache table. So you can view your ARP cache table by, say, going to the command prompt, and you can execute the command ARP space -a. ARP hyphen or ARP space -a. This is the command to view the ARP cache table. Clear? Okay. So, Smith, any doubt? So Shelva, I just saw your message that you'll be like joining online. Okay, just now only I saw your message. Okay, so guys, shall we take a break then? Or now, okay, just before giving a break, we have almost come to the end of OSI. Okay, so data link layer we have discussed, right? All the functions we have discussed. Now, the physical layer we have already discussed. So the physical layer involves the cabling, those things and all, right? We have already studied the cables. Okay, so physical layer, and one more thing to tell you. So physical layer is where the hub works. It is where the hub works. Clear? So those things are regarding the physical layer we have already completed. Clear? Okay. So this is the OSI, and one more thing, just 2 minutes, guys. Okay, so let me tell you the difference, the basic difference between, so I told you we got OSI layer and also we have got TCP/IP layer. Yes, TCP/IP model. TCP/IP and OSI. So the basic difference is that, say, the OSI you got 7 layers. You got 7 layers: application layer, presentation layer, session layer, transport, network, data link, and physical. So the TCP/IP layer or the TCP/IP model, it has got 5 layers here. Sorry, 4 layers here. So the first is called application layer. So application, presentation, and session have been grouped together as application layer. And the transport layer is now called host to host layer. And the network layer is now called internet layer. And the data link layer and physical layer have been grouped together and it is called network access layer. Clear? So this is the difference, the basic difference between the OSI and the TCP/IP. Clear? So this is the OSI model. Okay. Now I'll give you guys a break. So the break, and after the break, and I suppose You guys are familiar with the IP address and everything, because after the break, we are going to discuss more about the IP addressing, the network address, the broadcast address, so and so things. Okay. So if at all you feel you are not confident with that, you can revise it, or else if you are feeling confident, then you can take the break. Okay. So you can take the break till 6:45 p.m. It's 39 already. Okay. Yes. Yes. So guys, now we'll go with a topic called, we'll start a topic called subnetting. So you can write the heading subnetting. Okay. Now, today, let's see how far it goes. So now, suppose I'm giving you an IP 198.199.200.201. This type. Which class it belongs to? Class C. I suppose I heard B somewhere. Okay. Is it Raghavendra? Sure. Okay. Did you tell class B? Class C only. Okay. I thought I heard that. Okay. No issues. Now, what is the default subnet mask? I didn't hear. 255.0. Guys, I suppose you had enough like tea, coffee, and whatever things that you need. More and with more energy. 255 dot? I hear 255, 255 and all. Okay. Now 255.255.255.0. Okay. And even the online guys, from the online guys, I suppose I heard only one voice. Okay. So now, what's the network address?
198.198.0.
198.0.
199.200.
Okay. Okay. So now I suppose everyone's telling the right answer. Okay. So now, okay. So who will tell me the next answer? Say suppose online guys. I suppose yesterday I didn't ask any online guys about it. So who will tell? Say suppose Subhash has already told. We'll start with, okay, Salman, I'm confident. Rakesh. So tell me the broadcast address for this one. I suppose Rakesh is here. You there, Rakesh? Yes. 198.199.200.250. That's very good. So 198.199.200.255. Okay. And Selva, okay, yesterday he was answering, yesterday he answered, right? So now Subhash or Kavya. We'll go with Kavya. So Kavya, can you please tell me the assignable IP?
198 dot 199
199 dot
200 dot
200 dot
1 to
2. Yes.
198 dot 199 dot 200 dot 254.
Exactly. Very good. Okay. So this is the assignable IP. Thank you, guys. Now, so now let me tell you. So here, how many assignable IPs you have got? 254 assignable IPs you have got. Okay. So that means 254 IPs can be seated or 254 IPs can be placed. Now, let me ask you a simple question. Suppose we have bought, suppose today is, whom shall I take? Deva's birthday. Okay. Today's Deva's birthday. Now we have bought, suppose we presume that everyone, say suppose in classroom, I suppose 20 people are there. All the 20 people will come. We have assumed it like that. And we bought 20 kilo cake. We bought 20 kilo cake. We bought 20 kilo cake. Now, so here suppose only 10 people came to the class today. Only 10 people came to the class. So we will say give. So our planning was to give each people 1 kilo each. That was our plan. Okay. Now only 10 people came, and now we got 20 kilos. So, and each people, they are telling they can't, let's say like maximum they can go with 1 kilo cake only. That's it. So what we are going to do, we are going to cut it into smaller pieces. We are going to cut the cake into smaller pieces. Okay. So 1 kilo, this is 1 kilo, this is 1 kilo, this is 1 kilo, this is 1 kilo, and this is 1 kilo, this is 1 kilo, and this is 1 kilo. Everything is 1 kilo. So we are cutting into smaller pieces. Okay. Now, and we have given it to 10 people. Okay, we have given it to 10 people. And we have saved the rest to maybe tomorrow. Suppose the other 10 people will come tomorrow, suppose. Okay, then we have saved the rest to other 10 people who is going to come tomorrow. Clear? So here, same thing. Suppose you have some IP addresses, or how many IP addresses you have got? 254 IP addresses you have got in this network. So suppose you got only 10 machines here. You got only 10 machines here. Okay. If you got 10 machines, you can assign the computers with an IP. Say suppose the IP can be 198.199.200. Say 10 can be the first one. .20, .30, .40, .55, .68, .71. If I assign random IPs, then I really can't assign, or I can't give, say suppose if I'm telling you that instead of cutting the cake like this, so we are randomly cutting the cake. So suppose this is the cake. So suppose Vaman has cut the cake like this, and Deva has cut the cake like this, and suppose say no, not this one. Okay, because okay, I don't want to like nothing. Okay, so now Susmit. So Susmit is cutting the cake like this. Okay, now Ashwin, right? Okay, so Ashwin, see he's cutting the cake. So if we cake the middle cakes like, or the middle pieces like this, then that will become a waste. The entire thing will become waste. So what we are going to do is we are going to cut the cake, say in a special manner, or we are going to properly cut the cake. Clear? Or we are going to say cut the cake in a proper manner, or we are going to assign the IPs in a proper manner. So if you got 10 machines, then you will assign the IPs like this: .1, .2, .3, .4, .5, .6, .7, .8, .9, .10, like that. We are gonna say yes, arrange it in a specific, or we'll be like creating a small group and we'll be assigning it, right? So that the later IPs can be assigned to some other network or some other machines. Clear? And this process, so what we have done is we have a big network. So we will be dividing this network into multiple subnetworks. We'll divide this network into multiple subnetworks so that the IP wastage is avoided. Clear? So whatever is required, we'll cut it. Okay, whatever is like, say, the rest of the things we'll save it for, say, maybe for another day or another network or whatever it is. Clear? Okay, so this is the process of subnetting in a nutshell. Okay, so what we are going to do is, if we have a big piece of network or big network, then we are going to cut it into smaller pieces. Clear? Okay. So now let me tell you. So suppose. So what I'm going to do is that I told you this big network is cut into smaller pieces, subnets. Okay. Now again, let me go with another example, or let me say this is a big network. This is a big network. So as the first IP, we got a network address. And at the last, we have got the broadcast address. So here we got, at first we have got a network address, and at last we have got the broadcast address. And in between, so where is it gone? Just a moment. Yeah. So in between what we have is called assignable IP address. It's called assignable IP address. You already know this, right? What we are going to do now is we are going to split this into smaller subnetwork. We're going to split into smaller subnetwork. And each subnetwork here will have, say, this is a block of subnet, or this is the piece of subnet. Now this subnet will have their own subnetwork address and their own broadcast address. Their own subnetwork address and their own broadcast address. And in between you have assignable IP address as well. Clear? Okay. The same thing. This is the second subnet. Okay. So now this is the subnetwork address and this is the broadcast address. And here you have assignable IP address. Clear? Now the same thing. This is the subnet address or the subnetwork address. This is the this is the subnetwork address, this is the broadcast address, and this is the assignable IP. So what we are going to do now or do today is that we are now, or I'll be giving you some questions, okay, about the subnetting question. And what we are going to do is that, or I'll be making you write a table. I'll be making you write a table. Okay, so the table will contain the subnetwork address. It will contain the subnetwork address, broadcast address, and the assignable IP address. Clear? Okay. So again, one more thing. Let me tell you one more thing here. So subnetting, I'll be teaching you in my own method. In my own method means it's a little bit harder. It's not actually my own method. It's the actual method. It's a little bit harder. Okay. Once you have written this table, maybe tomorrow you will be writing, or yeah. And guys, let me remind you, or just remind me to tell you about the class on Monday. It's a special thing. Okay. So now, not the class, some other thing as well. Okay. So you have got subnetwork address, broadcast address, and assignable IP address. Now, once I make you write this table, you can check the table. You can check the table. You can check the table for, say, the network address, the broadcast address, and the assignable IP address. And you can come up with your own method, or you can come up with certain shortcuts. Okay. So after, now you will not understand, but later when you check this table, you will understand later. Okay. So I'll be making you write, say, the table here, and it's a lengthy process really. Okay. After, say, 2 or 3 questions, I won't tell you to write it with, say, the lengthy process. You can conclude with certain shortcuts. You can write it on your own. Clear? Develop your own method. Clear, guys? Okay. So now, shall we start the class? I mean, shall we start the subnetting? Okay. So now, my requirement, say, I'm giving you a question here. Say, suppose the same question. Okay. So here, this question is 198.199.200.201. So this is the question. So suppose, let me write it down. So 198.199.200.201. Okay. Now, and you will have some requirements. So my requirement is to divide it. Say my requirement is like this. 60 subnets, or say, sorry, 60 machines per subnet. 60 machines per subnet. So let me tell you what it is. Okay. So this is a network. This is a large network which contains 254 assignable IPs. And now I want to divide this into smaller pieces such that each subnetwork, this subnetwork will contain 60 machines. This subnet will contain 60 machines. This subnet will contain 60 machines, and this subnet will also contain 60 machines. Clear? Shall we? Okay. So now, so let me now tell you how to do it. So first we are going to write down the class and the network address. So you know the class, which is class C. For class C, the network address is, say here the network address is 198.199.200.0. Yes, exactly. 0 is the network address. Now I've drawn a line like this. What I've done is I've drawn a line. Okay, to the left side of the line, you have network portion. To the left side of the line, you have network portion. Now, to the right side of the line, you have host part or the host portion. So now let me expand the host portion. So I'll expand it like this: 0, 0, 0, 0, 0, 0, 0, 0. Okay, now, so here, and again, we'll be writing the values. We'll be writing the values. So the values will be 1, 2, 4, 8, 16, 32, 64, 128. Okay. So now 1, 2, 4, 8, 16, 32, 64, 128. Okay. Now, so our requirement is 60 machines per subnet. Okay. Our say requirement is 60 machines per subnet. So what we are going to do is that, say we got the requirement 60. So we'll be checking where will our requirement come or where the requirement will come. So our 60 machine requirement will be coming in between this 64 and 32. Okay, it will come in between 64 and 32. Okay, so now I'll be drawing a line between this 64 and 32 like this. Clear? That means what I have done is, everyone clear?
Yes.
Okay, there at last. Okay, so now what I have done is I've extended the network bits. I have extended the network bits. Okay, so now here this extended portion is called subnet portion. It is called subnet portion. Okay, so how many bits you have got in the subnet portion? 2 bits you have got in subnet portion. So these are the 2 bits. Clear? Okay, so now if you have 2 bits, how many values you will have? If you have n bits, I've told you the equation, 2 raised to n values you will have. So if you have 2 bits, you will have 2 raised to 2 values, which is 4. So that means this entire network is divided into 4 subnetworks. The entire network is divided into 4 subnetworks. So this is the first subnet, this is the second subnet, third and fourth subnet. Okay, so now what we are going to do is we'll write the combination. So if you have 2 subnets, you can write the combination like this. I suppose you know how to write the combination, right? So we'll write it like this: 0, 0, 0, 1, 1, 0, 1, 1. Okay. So this is the combination. Clear? Now let me write the table. Now let me write the table. Okay, the table will be somewhat like this. So where is it? It'll be subnet portion, subnet. Okay, or the subnetwork address. It's the subnetwork address. Then you have the broadcast address. And finally, you have the assignable IP address as well. The assignable IP address. Clear? Okay. Now, let me tell you the subnetwork address, broadcast address, and assignable. So what we are going to do is that we'll be finding each subnetwork address, the subnetwork address of each subnet, the broadcast address of each subnet, and the assignable IP of each subnet. Clear? Okay. Now, let me tell you how you can write it. We'll write the network portion exactly like that. Okay. So guys, I suppose if at all you have any doubt, you will ask me at that time itself. Okay. So now, the subnetwork address, or we'll write the network portion exactly like that. That means we'll write it like this: 198.199.200. Okay. Now, this is the first subnet that we are going to find. Okay. That's the portion of the first subnet that we are going to find. To find the subnetwork address, or to find the network address, we will make all the host bits as 0. We'll make all the host bits as 0. So we'll make how many host bits you have it here? 6. So anyone having doubt? Okay. So you have 6 host bits. So all the 6 host bits will be made zeros. Clear? So the 4th octet, everything has become 0. Okay. So the value also will become 0 here. Clear? Okay. So this is the value. This is the first subnetwork address. Clear? This is the first subnetwork address. Now, going with the broadcast address. Okay. To find the broadcast address, you know, all the host bits will be made as 1s. Okay. So now what happens is that we'll make all the host bits as 1s here. We'll make all the host bits as 1. So the address here, the network portion will remain the same. So the network portion means, say 198.199.200. will remain the same. Then this portion, okay, the subnet portion is 00. It's the first subnet's broadcast address that we are going to find. So this value will be 00. Okay, and we have made all the host bits as 1. And now to find the value, we will add all these values. Okay, wherever you are having 1, we'll add all the values. So this one, the value is 1. For this one, the value is 2. Here the value is 4. Here the value is 8, 16, 32. So when you add all these values, 32, 16, 8, 4, 2, and 1, the value that you're going to get is, it is, say, let me write it completely. 198.199.200 remains a constant. And when you add everything together, 32 plus 16 plus 8 plus 4 plus 2 plus 1, 63. So the broadcast address is 63. Clear, guys? Okay. The same thing, you're going to repeat it for, say, now, again, one more thing. You will find out the assignable IPs as well. For finding out the assignable IP, say, we'll be giving one, or the assignable IP will be in between the network address and the broadcast address. Okay, so the assignable IP will be 198.199.200.1 to 198.199.200.62. Clear? So this is the assignable IP. Now, regarding the next one, we're going to find the subnetwork address of the next one. Okay, so I told you the network portion will exactly remain the same. 198.199.200 will exactly remain the same everywhere in this case. Okay, so let me write it. See here, the subnetwork address is 198.199.200. Okay, and the last octet, this value. So now we'll take the subnet. This is the second subnet. We'll take this value 01. Okay, now to find out the subnetwork address, you know, all the host bits will be made to zeros. So what you're going to do is that 0, 0, 0, 0, 0, 0. Clear? Okay. Now to find out the subnetwork, so this value, this address, the 4th octet address, say we'll take this value. So what is the value here? The value, yes, 64, because you have a 1 here. And what is the value of 1? 64. Getting it? So we don't have any other value to add. So the value is 64 here. Clear? Okay. So what you're going to do is you're going to give the value dot 64 here. Okay. Now we are going to find out the broadcast address. So to find out the broadcast address, we'll make all the host bits as 1. Clear? So the network portion will be exactly the same. 198.199.200. Now to find out the broadcast address, yes, we have 0 and 1 here, which is already there. Along with that, so you have the value 64. So along with 64, you will add, say, these values 32, 16, 8, 4, 2, and 1. Exactly. So you will get, when you add everything, you are going to get 127. Everyone getting it? Pakka? Okay. So now, so this is 127. Okay. So now, say 198.199.200 200.65 is the assignable. Say it is between, it will be between this subnetwork address and the broadcast address, which is 64 and 127. So it starts with 65. 2, you can say 198.199.200.126. Clear? In the same manner. Okay, everyone understood? Okay, so what about the online guys? Kavya, Selva, Rakesh, Salman, and Subhash.
Got it, sir.
Okay, so now, if at all you have got it, can you write the next 2 answers on your own? Take your time. Okay, take your time and write it. Okay, yes. Okay, Salman, we'll wait for others to complete, then we'll discuss. Okay, yes, we'll just give them 5 more minutes or let them take their time. Okay. So guys, if you have completed, you should have told me, right? Rakhu, done. Okay. So now you're also done, right? Okay. No. Okay, we'll discuss. So guys, you can check. So I'll be writing down the answers. If at all you want me to discuss, let me know. Okay. So here the third. So I'm not in it now. Okay. So now the third one. Okay, subnet portion will always be. Say no, the subnet portion will not always be 2 raised to 2. It depends. Say here we have 2 bits. Say maybe in the next question I'll give you some homework question. At that time, say you will be having more subnets. Okay. Oh God. Okay. So are you guys okay to discuss? Right. Okay. So now, so here the first subnet here. Say again. Just give me a moment. Let me delete it. Okay. So now. Yes, guys, anything to discuss? Okay. Now the fan and everything is gone. Your voices will be heard loud and clear. Okay, whatever you mama will be heard loud and clear. Okay. Yes. Now, so here again, so let me write it. So here the subnetwork address is 198.199.200.128. Everyone got it? Yes. Okay. Now the broadcast address. So guys, on the online guys, if at all you want me to discuss, let me know. Okay. So 198 dot means discuss more how you got it and all. Okay. So this broadcast address is 198.199.200.191. Okay. 191. Okay. Now the assignable IP will be 198.199.200.129 to yes 190. Yes, right answer. Now the last one, the last subnet, you can say this is the subnet address is 198.199.200. Exactly 192. Now the broadcast address is 250. And the assignable IP is 198.199.200.193 to 198.199.200. Exactly. So I suppose everyone is able to do it. Right. Now, so Smith, yeah, want to discuss anything? No? So now, so here, let me tell you what we have done is we have divided. This is the big subnet. We have divided it into smaller subnets. Okay, or the big network, and we are divided into smaller subnets. Now here, say the first subnet starts with .0 and it ends with .63. Right. So the broadcast address is 63. That means it ends with .63. Okay. Now the next one starts with 64. Okay. So the next one starts with .64 and ends in .127. The broadcast, nothing. Okay. So it means, say, the network here starts in subnetwork address or the network address and ends in the broadcast address. Clear? Okay. The same thing. The second one will start from 64 to 127. And in between, you have the assignable IP. Clear? So it ends at 127. Okay. So .127 is where it ends. And the next one, say the next one is .128 to 191. Okay. So it starts from .128 and ends at .191. Going it in a continuous manner. And again, we are just stopping it. That's it. Okay. So getting it? Yes. Okay. So now, and again, the last one is starts from .192 and ends at .255. Clear? Yes. Everyone? Yes. Okay. There? Yes. Okay. So now, So here assignable IP is from .1 to .62, say .65 to 126, 129 to 190, and 193 to 254, like that. Okay. So this is how you will submit. And it goes in a continuous manner as well. Clear? So here when you check, okay, when you check here, the assignable IP is from .1 to .62. So that means 62 IPs are there. 62 assignable IPs are there. So when you count the number of IPs here from 65 to 126, how many IPs are there? 62 IPs are there. 62. Here also 62 IPs are there. Here also 62 IPs are there. So now let me tell you how to find it. So you already know the number of bits. Say you have 6 bits here. In the host portion, you have 6 bits. Say the number of values will be 2 raised to 6. It means 2 raised to 6 is, what is it? 64. But you have to decrease the network address and the broadcast address, -2. So your value will be 62. So in each subnet, you got 62 machines. Clear? So our requirement is to have 60 machines per subnet. But now we are having 62 machines per subnet. That is okay. Say suppose some extra IPs, let it be there. Maybe later we can give it to some other machines. Clear? Everything okay?
Yes.
Okay. In that case, let me give you some example as well. We'll wind up the class, say within 5 minutes. Okay. So here, let me give you some homework. So homework 200.120.150.180. And my requirement is try to do it. Okay. Only you have done a single question. I know that. Try to do it. Whoever is not able to do, say you can try it. That's all. Don't get demotivated or say like get frustrated or whatever. Okay. Try to do it. So now the requirement is 30 machines per subnet. 30 machines per subnet. And the next one, say 220.240.158.159. And this time let it be 10 machines per subnet. Ten machines per subnet. So these are the 2 homework questions. Okay. So now let me stop recording. Okay. Yes. So now, okay. So now let me stop recording.